This is 4.3, lesson 1. So we're continuing to talk about scatter plots. So for this lesson, we are going to make predictions from our trend lines. So by using the equation for the line of best fit, we can predict the outcomes for any input. That should be an N right there. There we go. Any input. So be careful to plug in your number to the correct variable. Sometimes we'll plug it in for X and sometimes we'll plug it in for Y. So you want to make sure to check your labels on your X and Y axis to determine which one you will use. So looking at our first equation, or our first graph here, I give us the line and we need to write the equation for this line. So in order to write an equation for a line, we need two good points. So let's take a look here. This is a good point, and we'll say this right here is another good point. So again, just like yesterday, to write our equation, you have two options. You can make a table of your x, y values, or you can do rise over run. So our first point is 810, and our second point is 16.4. So we see that our change in y is -6, and we would see that by going down 6 in our graph. And our run, or our x, our change in x, is a +8. So again, make sure you're paying attention to our scale to know that it was +8. So our slope so far is -6/8, but we always want to simplify this if we can. So this is going to give us -3/4. So far for our equation, we have y equals -3/4x. And now we need to find our backup. So again, you can find your backup by plugging in an x value and figuring out how far you need to move to get to your y. Or if you want to make a table, you can do that as well. So our first x value is 10. Our m is -3/4, and our y value is 10. So our first x value is 8, I'm sorry, and our y value is 10. So we're going to go ahead and do 8 times -3/4. That's going to give us -6. So in order to move from -6 to +10, you would do 10 minus -6, or that would give you a +16. So here's our equation for this line. And then our next question says to predict the hours of physical activity for a 12-year-old. So we know that's a 12-year-old, which means that we know the age. So when we know the age is on our x-axis, which means that we are going to plug in 12 for x. So we have y equals -3/4 times 12 plus 16. So when we do 3/4 times 12, we get -9. We have -9 plus 16 gives us 7 hours. Now if you look at our first two graphs, they are actually identical, so we've already done the work to find our equation. So we have y equals -3/4 x plus 16. But this time it asks us, if you have 12 hours of physical activity, how old would you be? So this time we know that we have 12 hours, and hours of physical activity is our y. So this time we are going to plug our number in for y. So we will have 12 equals -3/4 x plus 16, and we need to solve for x. So we'll subtract 16 on both sides to get -4 equals -3/4 x. We will divide by -3/4 on both sides. Okay, when we divide that, we end up getting 5 1/3 years as our age. Now sometimes people like to ask, well, why can't I just look at my y over here 12 hours and just predict what my x is? Well, we can see that it's not perfect. It's not perfectly on the corner of a square, so we don't know exactly what it is. And we can see that in our answer. We got 5 1/3. The same thing goes for this one up here, this prediction. When we know that our x is 12, we saw that our point, we would have hit it right here. But again, we don't know exactly what that is. Even though it kind of looks like the middle, we don't know for sure. That's why we have to plug in our numbers into our equation to find the exact answer. So let's flip it over to the next side. So again, the first thing that we need to do is write an equation, which means that I need to find two perfect points. So it looks like this is a perfect point and this is a perfect point. Again, we want points that are on the corner of a box. So my first ordered pair is 25, 6, and my second one is 40, 12. So now we need to find our change in y. Our change in y is plus 6, or if we did a rise, we would see that we have a rise of 6. Then our change in x is plus 15, which means that we have a run of 15. So our original slope is going to be 6 over 15, which simplifies because they're both divisible by 3. So we're going to get 2/5 as our m, as our slope. So far for our equation, we have y equals 2/5 x. And again, we need to find our b. You can either just plug in your x and multiply 2/5 times your first x and see how far you need to move, or if you need to make a table, you may do so, whatever works best for you. So my first x is 25, my m is 2/5, and my y is 6. So we have 25 times 2/5 is going to give us 10. We want our answer to be 6, so to move from 10 to 6, I would subtract 4. So there's our equation, y equals 2/5 x minus 4. Now it says to predict the number of assisted tackles if the player has 25 solo tackles. So when we talk about solo tackles, we see solo tackles is on our y-axis, which means that we need to plug in 25 for y. So we're going to have 25 equals 2/5 x minus 4, and we need to solve. So the first thing to solve would be to add 4 on both sides. So we get 29 equals 2/5 x. So then we would do 29 divided by 2/5 to get 72 1/2 equals x. Now what I want you guys to realize, if I had to predict 25 tackles, we see 25 is not even on this graph, which is why it's really important that we write our equation to make predictions, because a lot of the times these numbers that we're trying to find the prediction for will not even be on the graph. So when we look at our second graph here, it's the exact same one. So we can just rewrite our equation, y equals 2/5 x minus 4. So it says predict the number of solo tackles if the player has 75 assisted tackles. Okay, so assisted tackles is our x-axis, which means we are going to plug this in for our x in our equation. So we have y equals 2/5 times 75 minus 4. So when we do 2/5 times 75, we get 30, but then we have to subtract 4, is going to give us 26. So we see that assisted tackles, 75 is not even on here. It's only going to go up to 65. So again, that's why we need to have our equations. So we have 26 solo tackles.